Okay, good morning everyone. Welcome back. I hope you rested well and welcome back to day 2 of your training. So I'll be taking you through lab 4, which is sensor subsystems. And as you have learned yesterday that you have done the on-board computing and tested your embed, and at the same time you have done your power system. And today we are going to look at, and you have done also the command and data handling. Today we are going to look at the sensor subsystem. So this is the content that we are going to follow. We're going to look at the introduction, and then the functionalities, then the process, the architecture, and the sensor subsystem itself, as well as the hands-on bit, which is interactive testing, assembly, integration, and testing. So if we can compare to human beings, the sensors, they are those things that we see, our eyes, they are the ears, and they are the noses that we use to apply our senses. The sensors, they can detect the environment, and they can also see, and they can capture. So in this case, when we talk about the sensors, they will detect the conditions both within the satellite itself. This is the final product that you will have. And within it, you need to install some sensors that will detect the conditions of the satellite inside it. Because as you imagine, you are loading it with different programs, and you want the satellite to do some functionalities. So for you to be able to know how the conditions are, sometimes you can overload your satellite with too many programs, and as a result, it will start heating up, injecting some energy, and so you need to detect the conditions of it. And this is what we call the conditions within the satellite is what we call the housekeeping data. Housekeeping in the manner that within the satellite, it could be too hot to perform a mission. It could also, the battery could be depleted, and it can no longer function or produce your mission data. So things like temperature, acceleration, where the satellite is and where it is going, it's very important for you to know. And once it comes within your visible range, you need to detect these conditions so that in case you need to have a corrective mechanism, you have to command the satellite to operate in that mechanism within that physical range. Then you have other sensors that detect the external conditions, and this mostly are what we call the mission sensors, e.g. the camera. If it's another observation mission, you need to capture images in your area of interest and to send that data within your ground station. So they are digital and analog sensors according to their data format, and we are going to see that in a couple of slides that are to come. So you're familiar with this slide already, but I wanted to concentrate on this part, because you see the two arrows are what we call the downlink and the uplink. Uplink is what you use to send a command to the satellite, and the downlink is what the satellite gives you as a feedback. So between the ground station and the satellite, you have to perform some tasks. Some of it you have tested it yesterday by using the embed as your satellite for now, and the computer as your ground station. So you set some commands, and the satellite gives you some feedback. So the uplink and downlink is working. You have tested it already. So within this range, when your satellite comes to your visible range, you need to command it to send you the conditions within the satellite, how hot it is and how the temperatures are, the normal conditions, and the acceleration, where it is, how fast is it going, and it's very important to detect the acceleration because it's a determinant in the orbit. It could be moving out of orbit and you need it to be in a certain orbit. And also the location. we are going to see the GPS sensor that we are supposed to install, and it's supposed to give you certain location of the sensor, of your satellite. So that if it is in the wrong location, then you might need to send another command uplink and move it in the right direction. So the physical structure is like this architecture. You have these parts that are yet to be connected, and you need to establish that communication. This is your embed, which is where we can call the brain of the satellite is. And from this, you need to install your sensor so that you can detect whatever condition that you want to have. So we have to establish the communication of the sensors with the embed. So everything is going to the embed because it's where the brain of the satellite is. And from there, you can perform different tasks. So this is how we are going to do it. In our HEPTA-SAT, we don't have actuators, but in a normal satellite, you might need actuators. But we have the analog sensor. We are going to see which one is analog and which one is digital. And you have a digital sensor. Then the structural subsystem is the outer casing of the satellite, which you will assemble together. So when you have an analog sensor, remember that our MPU is digital. So you need to amplify the signal and subject it to a filter mechanism and move it to the AD converter, analog to digital converter. And as we had established yesterday in our lecture, in our lab 3, that we are using serial communication. Serial, we have synchronous and asynchronous, and my friend Timothy highlighted that. So within the embed, if we had actuators, we would also subject them to a modulator. So for analog sensor, what you do is you move it through the amplifier to amplify the signal, and then you filter it to remove the noise. Then you subject it to an analog to a digital converter, and then communication with the OBC. OBC is within the embed. Now let's come to the HEPTA-SAT. Within our HEPTA-SAT, we have four sensors that we are going to work with. Finally, we will install a GPS. We have a thermal sensor inside. The thermal sensor is to detect the temperatures and the thermal conditions within the satellite. The gyro sensor is for attitude determination and control. We don't have control within this model satellite, but in a normal satellite, you will have control subsystem. So the gyro sensor is a 9-axis sensor. It measures the acceleration, it measures the magnetism, and the gyro. And we have the location sensor, which is the GPS, and the camera. So we are going to install these four within this lecture, this lab. So, just to give you a quick view of where we are, the yellow subcomponents you have implemented on it. You have done the power system, subsystem, and you have also done the embed. And so we are going to concentrate on this part, the red part. So we are going to install these sensors and establish the communication with the embed. And as you can see, the thermal sensor is an analog sensor, so you have to subject it to an operational amplifier, and you have an amplifier, and then to the AD converter before it goes to the embed. And then for the 9-axis sensor is already digital on the camera and GPS. Analog switch because they are using the same port, the GPS and the camera. So you might need, when you're taking the photo, then you switch, the GPS is off. So you take one at a time. And then for the next lecture, which is lab 5, you are going to see the installation of the blue part. And this is what it looks physically. This is in the book, and you will see the pin assignment that you should assign in order to communicate with the embed. This is the sensor board which you are going to install. You see the thermal sensor is here, and you see the camera and the GPS. And there is an analog switch for them. And this is the amplifier for the thermal sensor. Then the 9-axis sensor is here. And it's very good, it's very important that you pay attention to the orientation of this sensor because it has some axis, but it's drawn for you to see it from the textbook. Yeah. Now these are the parts that you're going to require. You see parts 24, 32, 33, and these ones, they are structured. This is for the securing of the battery. But the sensors are the camera, you have the GPS, and the 9-axis, and the thermosensor, and the analog switch, and the amplifier. So this is where most of your work will be concentrated on in the structure, to assemble these sensors, the 4 sensors, within the sensor board and establish that communication with the embedded. So the process, the steps that we are going to follow is that we are going to physically secure the battery and interface it with the EPS. EPS we did yesterday, the power supply system, and we are going to secure the battery within the sensor subsystem and interface with the EPS. And then we start installation of the thermosensor, and there is a program required for that, which is you're commanding the satellite to start acquiring, to detect the temperature conditions within the satellite. Then we run the program and test it. Then we install the 9-axis sensor for the gyro acceleration and magnetometer, and we use this lab 2 to lab 7 to do that. And this is normally you are loading a program into the embed, which is the satellite, and to allow it to give you feedback on the housekeeping data conditions. And installation of the analog switch to the UART and the camera. And the GPS part, we will see how the situation will be, because the GPS part is a bit longer than the others. So we might need to push it to the end, but we're going to see the progress with you. If we are within the timeline, we can still do the GPS going outside and acquiring data and drawing it on a map. But if time is not on our side, we might have to do a demonstration and the camera installation. So we might do this part at the end because it takes time. And then we create the satellite program. And by the end of the lecture, we will have installed, tested, and run all the programs, and we will have interfaced them with the OSs, with the embed. And then we will have installed, tested, and integrated all the components to detect the housekeeping conditions, which are the internal conditions of the satellite, the health of the satellite within the HEPTA-SAT. And after that, we can call it a success. Okay. So, if there are any clarification or questions that you want to have before we start, feel free to do so. And even if the questions come within when you are doing the work, please feel free to call us to come.
Okay, just I want to make short announcement. So Meshack told you about the GPS exercise, which is to collect data and draw it in Google Maps. Leave it for the end, okay? But if some teams are fast enough, do it as you want. But by the end of the lab, Meshack will draw the map together with you. He will show it here on the screen, and you're going to do it simultaneously with him. Okay? And again, lunch is at 12:30 today. All right? Thank you.